In this video, we will learn about the variable and data types of C programming language. Let's do this operation, program to find the sum of any two integer numbers. Before start writing this program, let me tell you one thing. In our childhood, we did some algebra like this. If a equal to -1, b equal to 4, then what is the value of 2a plus 3b? In mathematics, we call this a and b as constant. A is initialized with -1 and b is initialized with 4. To find the value of this expression, replace a and b with -1 and 4. So the expression will become 2 multiply -1 plus 3 multiply 4. Now 2 multiply -1 is -2 and 3 multiply 4 is 12, and finally it gives 10. So 10 is the result of 2a plus 3b, where a equal to -1 and b equal to 4. Now if we want to do the same thing or the same operation within the C program, so what we will do? In this case also, we initialize two variables, a equal to -1 and b equal to 4. In C programming language, a and b are called variables. We can vary the value of these alphabets according to our choice. So these two alphabets are called variables in C programming language. You can also think in like this way, that these two variables are nothing but a container which contains some value. It may be integer, it may be a fraction decimal, or it may be a character. So here I have initialized a with -1 and b is initialized with 4. So these two are variables. Now in the next line I'm writing c equal to 2 multiply a. So in case of programming language, multiply is written as asterisk. So 2 multiply a plus 3 multiply b. So this is my expression. So it will evaluate to some result, and that result will be initialized within C variable. This equal to are called assignment operator. And this assignment operator are right associative. That's mean right hand side will be moved to the left hand side. -1 is initialized within A. 4 is initialized within B. So this expression will be evaluated and the result will be initialized within the left hand side, that is within the C variable. Now these three variables A, B and C are dealing with integer. The C variable also holds the integer value because the expression says so. So that's why we have to declare the type of the variable in the first line. So in C programming language, integer declaration is done by a keyword named as int, int, int. Now again come after this expression. Here we are going to print the value of C. So for that we require a function. This is an inbuilt function of C programming language. This is called the printf. And every function are ended with a parenthesis, open and close. Within printf, we have to write this variable c. So the value of the variable will be printed on the screen. Now to print an integer variable or the value of an integer variable, we have to write a %d. This is called a format specifier in C programming language. This is nothing but a symbolic representation to print an integer. So when the printf encounters a %d within a double quote, it will find an integer variable outside the double quote, and the value of the c will be printed in place of %d. In C programming language, we require this kind of format specifier. For integer, we have to write %d. For decimal fraction or float value, we require %f. For character printing, we require %c. So for different data types, we require different format specifier. I will show you everything after this presentation. For the time being, for integer variable, we need this %d format specifier. Now these are the lines for C programming language. So first of all, this is the data type declaration of variables. These are initialization. This is expression evaluation, and this is printing the output. Now each and every line in C programming language will be ended up with a semicolon. Now this line will be enclosed within a second bracket open and second bracket close. And this is what we called a block. And this block has some name which is called main block. In C programming language, this main block is called main function. Since main is a function, so it will be ended up with a parenthesis open and close. And within this parenthesis, arguments are optional. For the time being, I am writing nothing over here. From now on, we call this block as main function. In C programming language, main is the starting and ending point of every program. So this is mandatory. We have to write this main function in every program. Since this main function is doing some operation and printing the result right over here, it is not returning this value or the result to any other function or to any other software. So the return type of the main function is void. I will explain the return type in more details during function call mechanism. For the time being, write void main within each program. Now be very careful, there will be no semicolon after void main, after this brace or the second bracket open, and after the second bracket close. That means you have to remember where we are not writing the semicolon. So after the function, this void main function, after the braces, we are not going to write any semicolon at the end. But all the lines within the main function will be ended up with semicolon. Obviously, there are some exceptions. Now what the printf statement will do? Printf will display the value of C, and the explanation of printf is written within a file called studio.h. This is a header file, so I am writing .h. H means header file. This studio.h are supplied by the compiler, and this file is created by the developer. So this studio.h do standard input output. If we do not write this studio.h, so the program can't recognize this printf statement, etc. So this header file should be enclosed within an angular bracket that is less than and greater than, and it must be included in our program. This include is nothing but a keyword, and just write a hash in front of this include. This hash represent that studio.h is pre-processed. That means it is error free and it is pre-compiled. So when we compile our program, no need to check about studio.h. It will help to run our program. So in every program, we will write this header file studio.h, and that must be included by using the include keyword and a hash in front of it. Within the void main function, we are going to write our own program. So this is a complete C program. Let's run the program in the compiler first. So here is the include studio.h, then void main. Within void main function, let me declare three variables a, b and c. Now a is initialized with -1, b is initialized with 4, so there will be a semicolon after each line, and now c equal to 2 multiply a plus 3 multiply b, semicolon. Next printf, within quote there will be a %d, since we are going to display an integer variable, and after comma the variable c. The variable and the format specifier will be separated by a comma, again semicolon at the end. So Ctrl S to save the file. Let's run the program. Here is the output, that is 10. Now look, I am writing result equal to %d within the double quotes. Now look at the change in the output. So it will display like this, result equal to 10. That means whatever we are writing within double quote will be directly displayed within the screen, that is within the output screen. And in place of %d, the corresponding value of the variable will be displayed. Now if I change this expression as simply a plus b, so the result will be changed accordingly. So it will become -1 plus 4, which is 3. Now if I write, say, sum of %d and %d is %d, and outside this double quote I am writing a comma b comma c. Look what happened. So in the output it is showing sum of -1 and 4 is 3. The words sum and of will be directly displayed in the screen. That means when the printf encounters first %d, it will find the first variable to print. So the first variable is a, and the value of the a will be printed in place of first %d. So the value of a is -1 and it is printed in place of %d. Then again a word and will be displayed directly. and after that this percentage d will be replaced by the second variable b, and after is there is another percentage d. This percentage d will be replaced by the third variable, that is c, which is the sum of a and b. So this presentation of output is quite better than the previous one. Now look very carefully, the output is showing or displayed at the extreme top left of the output screen. Now if I want to pull down this output to the second or third line, for that we have to use some escape sequence. So I am writing a /n in front of sum. So look what happens in the output. Look, it leaves a line at the top and then it prints the result, sum of -1 and 4 is 3. Now if you want to give some horizontal tab in front of sum to shift the output at the right hand side, for that we require a /t. So look at the output, it leaves a line for /n and the result has been shifted at the right hand side for the /t. This /n and /t are called escape sequence. So whatever the character we are writing along with this slash will be considered as escape sequence. We will get the effect of the escape sequence, and these are the effect. /n is called the new line and /t is called the tab. We will learn more about escape sequence in the next video, and in this video we will concentrate about the variable and data types only. Now let me tell you the rules for naming a variable. A variable name can only have letters, both uppercase and lowercase, digits and underscore. The first letter of a variable should be either a letter or an underscore. There is no rule how long a variable name, which is called identifier, can be. Generally in C program we can use 31 character in a variable. Data types in C programming language. The data types in C programming language can be classified into 4 parts: the basic data type, derived data type, enumeration, and void. In this video, we will learn about the basic data types only. In my previous example, I have shown you the integer data type only. Now look, what are the other data types are: short, unsigned short, int, unsigned int, long int, unsigned long int, float, double, long double, signed character, unsigned character. And each of the data type has its corresponding format specifier. So in case of short, we have to write %hd or simply %d. For unsigned short, it is %uh. For int, %d or %i, you can write any one of them. For unsigned int, %u. Long int, %ld, unsigned long int, %lu. For float, float contains floating point value, that is decimal fraction. For that we have to write %f. For a very big floating point number, we require a double data type, and for that we have to write %lf. For a long double, %L f, small f. Signed character %c, unsigned character %c. Look at the third column. So whenever we declare a variable with this data type, the variable occupies some space within primary memory. So the occupied space are written in bytes in the third column. So whenever we declare a variable with short data type, the variable occupies 2 bytes of memory, and that variable is capable of holding this range of values, that is from -32,768 to 32,767. And all these size of the basic data types are given according to the 32-bit architecture. So the memory allocation may be changed in different architecture. Now for unsigned short, it also occupies 2 bytes of memory. Unsigned means it will store only positive values, and for that the range becomes 0 to 65535. For an integer, memory requirement is 2, and an integer variable can hold this range of values. And this is similar to short. Look at the long int, it occupies 4 bytes of memory. And look at the range, it can store a huge figure, and the range is also very big. And if we add unsigned in front of long int, the memory allocation will remain same, but look at the range, it starts from 0 and it is up to 4294967,295. Now the memory requirement of float, double, long double are 4, 8 and 10 bytes respectively. For the character, it requires 1 byte of memory space. But look very carefully, when we declare a variable with a float data type, the value will be represented with 6 decimal places. And if you require more decimal places, then you have to declare that variable as double. So in double, it supports 15 decimal places. And for the long double, it can support 19 decimal places. And within signed and unsigned character, we generally use unsigned character. Its format specifier is %C, it occupies 1 byte of memory, and it ranges from 0 to 255. And for the signed, it is from -128 to +127. Let me show you an example. Let's do this program. Write a program to find the sum and average of any three numbers. In the first line, I am commenting this line, sum of any three numbers. After that, hash include studio.h. So this is the standard input output file. Then void main, and within the void main, let's declare three variables a, b, and c. To store the sum of these three variables, we require another variable, say s. So within s, we will store the sum of a, b, and c. After that, we require an avg variable to store the average of a, b, and c. So the comment line will be like this: sum and average of any three numbers. This first line is inactive. It is called the comment line. So when a line in C programming language is started with double slash, so this is called a comment line. This is inactive. It will not take part in execution. Now after float avg, let's initialize a, b, c variable with three different values. Say a equal to 10, b equal to say 13, and c equal to, say I'm writing 23. There will be semicolon after each line. Now to find the sum, s equal to a plus b plus and c. To find the average, avg, we require the expression s divided by 3. Now after this line, let's print sum equal to %d, and outside the quote it will be s. Now after printing the sum, let's printf, let's give a /n, then average equal to, since we are now going to display the avg variable is declared with a float data type, so this time it will be %f. For float, it will be %f. Now outside double quote, the variable avg. So that's all. Let's run the program. Look, it is showing 46 and average is 15.0000. It is not showing any decimal values. The sum is correct, sum equal to %d, so in place of %d, it is showing 46. But in case of average, I think the value is incorrect. When 46 is divided by 3, so the answer is 15.333333. But in our output, it is showing no decimal places. All are zeros. So let's look why it is happening. The problem is lying within this line. For that, we are not getting any decimal fraction. So here s is divided by 3. S is an integer, 3 is also an integer. In C programming language, when an integer is divided by an integer, it always gives the quotient. That is, when 5 is divided by 2, it will not give 2.5, it will give 2. So when 5 is divided by 2, 2 multiplied to 4, and the remainder is 1. So this quotient will becomes in the output. Now when integer is divided by a float value, then we will get the result in float. That's mean when 5, this integer 5 is divided by 2.0f, f represent the float value. So 2.0 is a float value. According to us, 2.0 and 2 are the same thing, but in case of C programming language, 2.0 is float value and 2 is the integer value. So 2 and 2.0 may have the same value, but their data types are different. And in this case, it will give 2.5 in float. Now, if a float value is divided by an integer, it will give a float value. So when 5.0f is divided by an integer 2, it will give 2.5f. Now when a float is divided by another float value, the result will be a float value. That is, when 5.0f is divided by 2.0f, the answer will be 2.f. That's mean if any one of the numerator or denominator becomes float, the output will be in float value. If both the numerator and denominator are integers, then the quotient will be displayed in the output. So this thing is happening in case of this line. So when an integer variable s is divided by an integer number, it is generating the quotient only, and that quotient is initialized within AVG. And the AVG is not getting any fractional decimal part. So that's why it is showing 15.000000. So to run this line properly, either we have to convert this integer variable s to float, or we have to convert this constant 3 to float value. Let me show you how to do this. There are two ways. Either we have to write 3.0f over here. That means this integer s will be divided by this float value 3.0f. So the correct output will be generated, and that will be initialized within AVG variable. Let's run the program. Let's see what comes in the output. Look, this time it is showing 15.33333. So this is the correct output. Again, if you want to 3 as it is, then you have to convert this variable s to float. But this s is declared as an integer variable. So for the time being, you want to convert it into float value. For that, we have to write the type in front of this variable, and it must be enclosed within parentheses. So float is written within this parenthesis and is situated in front of the variable s. So this variable will be typecasted for the time being and for this line only. So the integer variable s is typecasted to float. Now the numerator becomes float and the denominator is integer. So if any one of the divisor or dividend becomes float, the result will be in float. So let's run the program again. Look, this time it is also giving 15.33333. So you can choose any one method as your wish. So this is all for this video. In the next video, we will learn about the escape sequence. Thank you.